Another example, let's plot our point first. 1 and 1, 2, 3, 4, 5. This is the point that we would have, our information would be 1, 5. So that becomes the point that is going to be substituted into this formula. Y minus, we're going to take our y point, 5, is equal to the slope, 2, times the quantity, x, minus, now our x value is 1. Y minus 5 equals, we're distributing 2x minus 2. Here's our wall. Remember, we're trying to take this formula and put it into this y equals mx plus b so we can graph it. We only have one point that we know about. All right, so we're going to reverse the subtracted 5. Y is equal to 2x plus 3. We now have our y-intercept. And we also know the slope. So we're going to plot our y-intercept at 3, 1, 2, 3. And then we would go up 2 over 1, because we can express this whole number as a fraction. So we're going to go positive. This is the change in the y-axis divided by the change in the x-axis. So we're going to go up 2 and to the right 1 from our point. We're going to go up 2 and over 1. Well, we've already hit our point that is on the graph. So our line goes this way. Let's check this out. Is that a positive slope? We've got the 2 is a positive number. So now all we have to do is mark our equation. Y equals 2x plus 3. You're now familiar with quite a few tools that can help you graph linear equations. You've got the standard form of the equation, the point slope, the slope formula with this one, this is graphable right now. You know how to find the slope if you're given 2 ordered pairs. You know how to find the equation if you're given 1 pair and the slope. And you are able to figure out distance and distance to the midpoint and the actual address of the midpoint. Those are a lot of tools to work with when you're working with linear equations. The situations where you would use this type of information would be if you have a, let's analyze the equation, and I'll analyze this equation. Y equals mx plus b. You know, you can always turn any of the others into this formula. We learned how we can, you know, play with the terms within the equation and move them from one side of the equation to the other until you get it to look like this. Or you can take this and make it look like the ax plus by is equal to c, that standard. But let's talk about this one right now. You have a situation where you have a constant. And you also have something that is multiplied by another factor. So this is like a multiplication piece. So when you are working with a story problem, let's say, a situation where you could easily use this type of math, you would want to have something that stays a constant. Like, for example, maybe your cell phone rate, cell phone monthly charge. And then this one would be, so this is a constant. You're always going to be charged, I don't know, $50 a month. Then you might get charged per text. So if you do 10 texts, you might be charged, you know, like 10 cents a charge, 10 cents. So if you make 10, that's the variable, your Y situation would change, your answer would change, but you're always going to pay the $50 every month. So when you have a situation like that where something's constant, or perhaps what you have is your salary, your salesman. So your salary is going to be, I don't know, 100. You get $100 just for showing up. But if you make sales, you're going to get 25% of each of the sales. So if you make 4 sales, if you make 7 sales, if you make 27 sales, this is going to reflect your Y. This is going to reflect your answer would be higher, higher, higher. But this is the charge you get just for showing up. And this is what you do for the number of sales. So you need to think about that when you're using your different formulas, because when you have a story problem that suggests that kind of information, you're looking for a constant and you're looking for some variable where this could vary depending on your ability to sell or your number of texts, how many texts you make. If you think of a graph itself, we did a lot on graphs, our X and Y axis actually were maybe time and perhaps it was distance. Maybe you had a distance calculation here. That's pretty messy. I'm going to take that off. Maybe we'd have distance here. So as we went up the Y-axis, those would be distance numbers, and across the bottom would be time. Those could easily be a one-to-one correspondence with your variables. So your X and your Y could be pulled from a graph. So these are some of the situations where you might use the tools of the linear equation. That's what you most likely will be tested on in some of the standardized tests. The ACT, the SAT has this on it, where you take the situation and decide which tools you're going to use. And then, of course, you have to be accurate and adept at using the tools, which would be the calculations with the math, just chugging through the math calculations. Linear equations.